45 years in space and we have a list of discoveries. Yes, we are talking about Voyagers that did make that list. Voyager probes, launched by NASA in 1977, are not an end to human curiosity but a part of it that knows no bounds. Despite having less memory than our smartphones and slower data speeds than 5G, these probes remain at the forefront of space exploration. But before we dive into today's video, take a moment to click that like button and subscribe to our channel. Be sure also to hit that notification bell so that you won't miss out on any of our upcoming videos. The Voyager probes may not come across a new planet or star anymore, but they will remain on the move unstoppably in interstellar space. After about 40,000 years, Voyager 1 is expected to come under the influence of the red dwarf star named Giza 445. There will be no travel destination for the spacecraft, but it will have a short-lived encounter with the planet's gravity. They are even believed to sustain communication with Earth until 2025-2030, after which they continue drifting into interstellar space. They will appear as tiny white dots on the expanse of the universe. One of the curiosities that comes to mind is, do the Voyager probes have a chance of communicating with another star system? It is highly improbable that these entities possess the scientific data as cargo, but there is a remote chance. The golden record with pictures, sounds, and a map to trace the Earth is an exciting memento from space exploration. There is nearly no probability that one of the Voyager probes will meet a populated star system. Moreover, when this happens, it can take many centuries. Let's touch on a unique aspect of the Voyager probes that we are personally in awe of: their data storage system. Astonishingly, these probes still use 8-track tapes, a technology popular in the 1970s. This choice reflects the ingenuity of the mission designers, as digital storage in its present form was still in its infancy during the early days of space exploration. These durable 8-track tapes, exposed to extreme temperatures, cosmic radiation, and the vacuum of space, hold precious scientific data about planets, moons, and interstellar space. The Voyager probe's ability to endure these harsh conditions is akin to sending your grandparents on a journey through Antarctica and having them not only survive but thrive. Another remarkable feature of the Voyager probes is their stability. Their design makes them rotate really slowly, like 15 times slower than your wristwatch. This helps them capture awesome images without any blurriness while traveling through space. The impressive imaging capabilities of the Voyager probes began to amaze scientists and the public even before their encounters with the outer planets. Transmitting images of Jupiter while still several months away, these early images showcased the turbulent clouds of the gas giant and the famous Great Red Spot, delighting audiences at NASA's Jet Propulsion Laboratory. Surprises did not stop here, as they also came up with active volcanoes on Jupiter's moon Io, the most volcanically active body in the solar system. The Voyager instruments managed to detect signals from Io, which included pictures of towering volcanic plumes and an erupted surface. Following their departure from Jupiter, one of the most interesting discoveries was the presence of a thin ring around Jupiter, which could hardly be noticed, causing much interest among astronomer observers. Voyager 2 demonstrated that one of Jupiter's moons, which was called Europa, had an ice shell that measured up to 93 miles in thickness and was way deeper than expected. The Voyager probes received an important gravitational boost on their way to Saturn, which helped them get out of the Sun's gravity and go deeper into space. Thereafter, Voyager 1 continued moving toward the Ursa Major constellation, while Voyager 2 proceeded onward toward the Cetus constellation. In 1986, Voyager 2 made a historic flyby of Uranus, discovering 10 previously unknown moons and increasing the planet's moon count. 3 years later, Voyager 2 reached Neptune, revealing the extraordinary features of this distant ice giant. As it approached within 4,800 kilometers of Neptune's methane atmosphere, it recorded wind speeds of over 1,600 kilometers per hour, making it the fastest wind ever recorded for any planet in our solar system. During its encounter with Neptune, Voyager 2 provided an exceptional view of Triton, Neptune's largest moon. Triton, one of the coldest places in the solar system, showed unique features, including ice volcanoes that spewed nitrogen gas and ice particles over 8 kilometers into the thin atmosphere. These discoveries expanded our understanding of the variety and complexity of celestial bodies, even in the most remote regions. All the credit goes to the renowned astronomer Carl Sagan for extending the Voyager missions beyond their initial objectives. As a member of the Voyager imaging team, he advocated for capturing one last series of images before shutting down the cameras on both probes. This persistence paid off on February 14, 1990, when Voyager 1 turned its camera inward toward the solar system and captured a series of 60 images. The most iconic of these, known as the pale blue dot, became an indelible symbol of our place in the universe. Taken at a distance of 3.8 billion miles, it is the farthest image ever recorded of our planet. Earth appears as a tiny, pale blue dot, barely observable in the vastness of space. The Voyager mission is an extraordinary tale of endurance and longevity, a triumph of human ingenuity and exploratory ambition. Even after 40 years, these probes continue to transmit valuable data from the most remote regions of our cosmic neighborhood. And with this, we can only tell you that we are only at the beginning of what we can discover in space. Until the next episode, hit that notification bell so that you won't miss out on any of our upcoming videos.